Hello student, welcome to the one more session of Computer Network and Security. This is Vasan Naik from Canara Engineering College. In this session, we will discuss today Open Shortest Path First Protocol, OSPF, Open Shortest Path First Protocol. Before that, we have already discussed these 2 points. There are 2 types of protocols on router which works on a router. One is called a routing protocol, other one is a routed protocol. Routing protocol, let me take you to the routing protocol is the protocol which is used by the router to compute the routing table. Once the routing table is ready, that routing table is used by the routed protocol to route the packet from source to destination. We know example for routing protocol. This is the example for routing protocols. You can see here, it is written here, the examples for routing protocol is RIP, IP, EIGRP, OSPF, BGP, etc. Example for the routed protocol, let me write here, example for the routed protocol is IPX or Internet Packet Exchange, or IP, in IP version 4, IP version 6, all these are the example for routed protocols. Let me explain once again. The routed protocol is used to transfer data from source to destination. In other way, the routed protocol carry the data, which makes use of the routing table. By making use of the routing table, routing protocol creates the routing table. With the help of communicating with each router, it will create the routing table. Now, other way of classification of the routing protocols. Now, other way classification of the routing protocols are, one is called as IGP, second one is called as EGP. IGP means Interior Gateway Protocol. This is IGP. IGP means Interior Gateway Protocol. EGP means Exterior Gateway Protocol. Now, what is this IGP? The protocol which works inside the autonomous system is called as Interior Gateway Protocol. So, in the diagram you can see here, this is the autonomous system, this is the autonomous system, this is one more autonomous system is taken here. So, the protocol which works inside the autonomous system is called as IGP, Interior Gateway Protocol. Now, what is autonomous system? A autonomous system is a collection of networks under common administrative domain. Under common administrative domain or rule. For example, particular organization want to apply some policies on the router which it uses. So in such cases, the organization make their own autonomous system so that they can adopt their own policy and they can hide the internal configurations from the external world. So, and they can adopt their own policy for routing and switching. So that is called as an autonomous system. So autonomous system is a collection of networks under common administrative rules. Here you can see 2 autonomous systems are there, and the protocol inside the autonomous system, the protocol which works inside the autonomous system is called IGP. What is the example for IGP? What is the example for IGP? The example for IGP, now, what are the protocol comes under IGP? The main protocol comes under IGP is RIP, Routing Information Protocol, IGRP, Interior Gateway Routing Protocol, EIGRP, Enhanced Interior Gateway Routing Protocol, Open Shortest Path First Protocol. These are the protocols. The main protocol comes under IGP. In that, IGRP is the Cisco proprietary protocol. We know what is Cisco proprietary. That works. These Cisco proprietary protocols works on Cisco routers. Then the protocol which connects 2 autonomous systems are called as Exterior Gateway Protocol, and for that the example is Border Gateway Protocol. This is also called as Path Vector Protocol. This is also called as Path Vector Protocols. So this is the difference between Interior Gateway Protocol and Exterior Gateway Protocol. So in our today's session we will discuss Open Shortest Path First. That is a IGP. That is a IGP. Open Shortest Path is IGP, but it is a link state protocol. It is not a distance vector protocol. Let me clarify here itself which protocols are distance vector protocol here. In IGP, RIP is called as a distance vector protocol, and IGRP is also called as a distance vector protocol. EIGRP is a hybrid protocol. It is a hybrid protocol, and Ospf is a link state protocol. We know the difference between distance vector and link state. Distance vector passes the update information in terms of distance and direction, and distance vector protocols are not robust. It is suspected to routing loops, but link state protocols are robust, and link state protocols passes in the link state routing, link state protocol routers, in the link state routers or the routers on which link state protocol runs, which will have complete topological database of the particular area. So link state protocols are less susceptible to routing loops. So with this, we will now proceed to Ospf. So open shortest path first protocol. It is openly available to public, and it is a IGP protocol. So here Ospf enables each router to learn the complete network topology. In the distance vector routing protocol, open state is a link state protocol. In distance vector protocol, it gets the information from the neighboring router. Based on that, it will compute the routing table. But in case of Ospf, enables each router to learn complete network topology. So that is the one point you have to remember here. So next one is, so here you can see here a group of routers where Ospf is configured, and Ospf follows hierarchical design. You will come to know what is a hierarchical design. So it is an open standard. Shortest path first, it will apply open standard, publicly available, and it will apply shortest path first algorithm. It will apply shortest path first algorithm, and it is a link state routing protocol compared to distance vector protocol. This protocol is the robust one and stable protocol. Next one is Ospf routers monitors. See here, very important points. Ospf routers monitors the link. Each link by using cost. That means it will Ospf makes use of the cost as the matrix to select the best route, and then floods the link state information in the other router in the network. For this reason, Ospf is called as a link state protocol. Why it is called a link state protocol means it will monitor the cost of the link by using a matrix called as it will monitors the link by using cost as the monitor. Cost as the metric, and based on that it will it will determine the best route, and it will flood that link state information to other router. Flooding of the link state information allows each router to build identical state database or topological database. Compared to distance vector, student please note, compared to distance vector, here each router will have topological database because it will get the information about the link from the other routers in the particular area of the network. It will get the link state information, cost of the link. By using that information, it will construct the topological database, and by applying shortest path first algorithm, it will compute the routing table. So here at steady state, at a particular state, all the routers will have the same link state database, and they know how many routers are in the network, and what are the interface, and what are the cost of the link, cost associated with the link, and it will use a shortest path algorithm, that is Dijkstra algorithm, and it will calculate the forwarding table or routing table. So as I said, open shortest path first protocol is the hierarchical routing. Hierarchical routing means here autonomous system, as I said, autonomous systems are divided into area. So Ospf consists of normally area and autonomous systems, and each autonomous system is divided into area, and there is a one area which is called as a backbone area. To that backbone area, other areas will be connected in hierarchical way. Other area will be connected. So this will minimize the flooding. And routing update traffic. It will minimize the routing update traffic. So let me take you to the other slide here. You see, this is the Ospf hierarchical design. So as I said, the entire autonomous systems are divided into different areas. All the areas are connected to backbone area. So we have router inside the particular area is called as internal routers, and the router which connects area to the backbone, this one area is called as area border routers, area border routers, area border routers. So here each router in the particular area will have the entire topological information of the area and all the information of all the routers in that area. Now area border router will summarize the reachability of this area to the other area by means of backbone router. So each area will summarize the information, reachability information about their area to the other area by means of backbone router. So in the diagram you can see there are three areas are there, and we have backbone routers, and backbone routers are internally connected to boundary router which will connect to the other autonomous system. For example, suppose if you have other autonomous system, then those autonomous systems are connected by means of autonomous system border router, autonomous system border router, ASBR, or boundary router, autonomous system boundary router, or autonomous system boundary router. So we have three classification of routers here, students. You should know what are the classifications. One classification is something called as internal routers, which comes under inside the area. Second one is called area border routers, which connects the area to the backbone area, and routers inside the backbone area are called as backbone routers, and the router which connects the two autonomous systems are called as autonomous system border router. So information from one area to the other area should move through the like area border router through the backbone router. Students, now we will see some of the important points from exam point of view related to open shortest path first. First point is it will calculate multiple same cost route to the given destination. Multiple same cost route to the given destination it will maintain. Compared to RIP will maintain only one route. It will maintain multiple same cost route so that load balancing can be done. Then second point is it will support hierarchical network design as explained earlier by means of area. Then here the main point is link state database reduce the chance of routing loops. We know in distance vector is susceptible to routing loops because of inconsistency in the routing table, but here Ospf makes use of link state database, and from link state database it will construct topological database. From topological database it will create a routing table, so less chance of routing loops. And fourth point is it will support classless routing. That means it will support variable length subnetting. It will support variable length subnetting. What is the use of classless and classful? In the sense like classful protocols, we are going through according to the classes, class A, class B, class D. In classless, if you go according to classes, you are going to waste entire range of IP addresses. So classless will make use of utilization of IP address properly. So Ospf will support classless, but RIP version will RIP version 1 is a classful protocol. Next one is decrease size of the routing table by the use of route summarization. It will make use of the route summarization that will decrease the routing table size. And routing updates are sent only when information is needed, decreasing the use of the network bandwidth. See, in the case of link state, in the case of distance vector routing distance vector protocol, every 30 seconds each router will send the routing update to the other router, and other router will process this routing update and it will pass the routing information to the other router. But in the link state protocol, once the database is stabilized, then after that routing updates are sent only when the information is needed, which will decrease the network bandwidth. So next one is it will use metric called as a cost, that is a more flexible metric cost, And distribution of traffic, OSP will support load balancing over multiple path, and OSP will use the multicast address to then broadcast address to reduce the load on the system. So in OSPF, the updates, OSPF routing updates are sent by using multicast update. Link state advertisement are sent by using multicast address rather than the broadcast address. Multicast address is nothing but sending update to a group of address, that is called as a multicast address. So use of designated router. Here OSPF makes use of designated router. Now what is this designated router? Designated router is nothing but in a particular area OSPF will select one router based on its highest priority. Priority may be taken as IP address, and that router, with that router, other router will establish the adjacency, and this designation router will act like a one point of contact, that is called as a designated router. By means of adjacency will be established, and link state advertisements are moved from moved to all the router by means of designated router. This is also called as a DR router. Then the terminology, OSPF terminology, you should remember the OSPF terminology. The first terminology is neighbor, refers to the connected adjacent router that running OSPF process and the ascent interface assigned to the same area. So neighbor in the same area, neighbor with respect to the particular area refers to the connected adjacent router, which are both are running same OSPF process. Then neighbors, so how the neighbors are found by means of allo packets. Each router will send allo packet to the other router, and on by receiving by means of multicast and receiving the update and by checking the other information, it will establish adjacency. So what is there in the OSPF allo packet? OSPF allo packet, each router will send the allo packet to the other router to establish neighborship. So the information it contains is router ID, area ID, which area it belongs, a network mask, the mask associated with the network, and allo interval, priority, which is the designated router, which is the border router, sorry, backup designated router. All these informations are exchanged while establishing the neighborship with the other router. So this is the packet format of the allo message. So allo message. Now next one is after establishing the neighborship, a logical connection will be established between the router and its corresponding designated router and backup designated router, and that is called as adjacency. So we know what is a designated router. As I said, designated router is a one point of contact to move the link state advertisement packet with the other routers in the same area. If the designated router fails, then we have one more router. So designated, that is called a backup designated router. Both routers are elected once the OSPF process runs. Now OSPF areas are similar to autonomous systems. So we have one more concept here, is called as OSPF area. So we know autonomous systems are divided into number of areas, partitions, and each areas are given by a particular ID, that is called as area ID. It is a 32-bit identifier. Then 000, like 0.0.0.0 area ID is used to identify backbone area. So you should know this point also. What is a backbone area? I have already told backbone area is the area where all different areas are interconnected. Now let us once again summarize this point. OSPF propagates link state advertisements rather than routing table. Very important points. Like distance vector protocol, we know distance vector protocol will send routing table from one router to the other router. This is the major burden on the processor. But on the other hand, OSPF propagates link state advertisement rather than the routing update. What is there in the link state advertisement? Which link state advertisement consists about particular link information. What is the cost associated with that link, other information, all those informations. So this is called as LSA. LSAs are link state advertisement are flooded to all OSPF routers in the particular area by means of multicast process. Then OSPF link state database is a pieced together from LSA generated by the OSPFs. That means from LSA it will construct the link state database. From link state database it will apply something called as shortest path first algorithm and it will construct the routing table. Now 4 types of routers are there in OSPF. What are the 4 types of routers, students? So one is called as internal router. I told you what is internal router. Second one is area border router. Third one is the backbone router, and fourth one is called as autonomous system boundary router, which will connect the one autonomous system to the other autonomous systems. I have already explained this one. Now I have already explained the hierarchy of that routing also. Now OSPF operation, how OSPF works. So with this we'll wind up. Let me explain OSPF operation. After that we'll wind up this session. OSPF runs over IP. Please remember this one. OSPF runs over IP using port number 89. So OSPF runs over IP. IP comes on IP works on network layer. So OSPF runs over IP using port number 89. Each OSPF packet contains a header. So OSPF makes use of 5 types of packet: allo packet, database description packet, link state request packet, link state update packet, link state acknowledgement packet. So you should remember 5 types of packets exchanged by OSPF. So what are those packets? 5 types of packets. These are the 5 types of packets. One is called as allo packet, second one is a database description DDP packet, third one link state request packet, link state update packet, link state acknowledgement packet. Allo packet is used to establish neighborship, then to establish like adjacency, it will make use of database description packet, link state request packet, link state update packet, link state acknowledgement packet. Once establishment is adjacency is established, after that it will create, once adjacency is established, after that it will create topological database. It will create topological database. From the topological database it will create the routing table by using shortest path first algorithm. So that is the algorithm is nothing but the Dijkstra algorithm. OSPF makes use of a Dijkstra algorithm. So these things you should remember. Next one is so all the packets are sent by using multicast address. This is the common header format. All these are like not there in VTU syllabus with reference to 18 CS 52 subject. So I will skip this informations, but you should know how it will operate. For that you should know it runs over IP and port number 89. It will use 5 types of packet. Then the operation is the first one is the neighbors discovery. It will discover the neighbor. Second one is the adjacency initialization. Adjacency will be made between the router and corresponding designated router. Then link state advertisements are flooded through with the different router. Then each router will maintain the, now each router will create the topological database. By using SPF tree calculation, it will calculate the shortest path first, best route, and that will be entered in the routing table. These are the operations of the OSPF. First one is the neighbors are discovered by means of allo message. Router will send the allo message by using router broadcast allo packet periodically on the network, and it will establish a neighbor. It will discover neighbor and establish neighborship. After that, adjacency requirement. After that adjacency initialization. To adjacency, there are 2 requirements. There should be 2-way communication via allo packets. Then 3 types of packets should be exchanged. What are the 3 types of packets? Link database description packet, link state request. That is, the router will requesting the link state information, and the router will get the update about the link state. All these packets should be exchanged. After that, adjacency will be formed. Once the adjacency is formed, then it will. Once the adjacency is formed, then each router will propagate this LSA to the other routers in the particular area by means of flooding, then after that it will create the topology database or topological database. Once the topological database is ready, then from the topological database it will build the routing table by using Ospf algorithm. It will build the routing table by using Ospf algorithm. So this is the information related to Ospf. So Ospf is a open shortest path first algorithm or protocol, open shortest path first follow protocol. So with that I will wind up this session. In the next session we will see what is border gateway routing protocol. Thank you.